Okay, we're gonna get things started. All right, we're ready to go. Just before we get going, we're looking for a Jabber scribe, if someone would be so kind as to do that. Look for some volunteers. Looking around the room. We'll need this to get going. We'll take care of the notes, so that's, you don't have to freak out about that, but we're still looking for someone who can help us with Jabber. Going once. Nobody wants to do any jabbering? No? All right, we'll figure it out. Want me to do it? All right, I'll do it. You guys have to talk a lot. Okay, so let's get going. Thank you very much for coming to IETF105, the LSVR working group. Co-chair's a little under the weather, so I'm going to try to do most of the talking. You have to put up with me. Please note the note well applies to the meeting. If you haven't read it, please read it. Here's our agenda. We'll take a moment to have a quick look at that. If anyone feels it's out of order or you want to make a comment, now is the time to do so at the mic. But if not, we will do some administravia to get things going. On the chair side, there'll be a call to action, quick presentation from Ignace, our AD. Then there will be a few presentations on some in-flight working group documents or yet to be working group documents. And then we'll have some closing comments and next steps. All right. No one at the mic, we'll keep going. So we had a number of key milestones that we had to work through over the last little while. As of March 2019, earlier this year, we had the applicability statement for LSVR and DCs adopted. It was the LSV distribution using BGP transport. That was adopted. We had the LSVR with standard extra path selection adopted. So those key milestones were met, so we're making good progress on that. We had wanted to get the Yang specification for LSVR going. There's still some work to be done there, and that will be addressed from some of the comments from Ignace and to sort out how we move on from there. And then we'll have a discussion around the L3DL, which was previously known as LSOE, adopted as a work group item. And that was a bit of a late adoption. From a working group status perspective, like I mentioned a moment ago, we seem to be doing reasonably well from a progress perspective. We had some aggressive timelines from the outset. We had wanted to make rapid progress given the state of things. There is an LSOE Python 3 demo available, so effectively an implementation people can play with and utilize. The link is there over in GitHub, free to use and to play with. As I said, and LSVR has made good progress as a main spec as well, and we'll get an update on that within this working group. Some documents that appear to be ready for working group last call was the applicability statement document and the BGP SPF document. We had talked about this back in March. What we'll do is we'll be a little more aggressive after this meeting to make sure we get the reviews in and get a number of reviewers identified and follow up with those reviewers, so we can get kind of a good long pass at those documents and make sure they're at a state where we can actually move them forward. So that you should expect that on the list after this meeting. And that draws close our introductory slide set. So there's no other comments. We are going to get ready then for, I believe it's Ignace is up next. So this will be, he'll talk to us about Yang and his feelings. Oh yeah, sorry, my bad. It's from the ops area, I'm sorry.
You can take the word.
AC Lindum Cisco Systems. Now, given that this BGP-LS, we're using a very small subset of it for SPF, given the whole universe of it. So how much we put into the initial, that's a question, doing it all, doing both BGP-LS SPF family and the regular standard BGP-LS address family would be good, but they're going to just definitely share some TLVs and things, but the amount of work is a lot different. I'm just making that point, so that's going to have to be a decision.
Okay, I'm not disagreeing with that, okay. But then again, this is for you as a working group who owns LSVR to decide what needs to get configured in order to get that used. And not only configured, basically, what state needs to get exposed and so on.
That would indicate we do enough to configure it, and from an operational standpoint, we'd set up a framework and do what we need for LSVR first.
Exactly, and that's the whole point, that the description of the configuration logic should be the focus, not the Yang code, but basically the logic how you use that.
So, K. Patel Arcus, I was simply going to ask you to clarify a little more, but before I do that, let me give you a status. I'm going to present the status on LSVR. We have device-based model very well hashed out. Mind you, that as AC said, the encoding in LSVR follows the formats of LS address family. However, there isn't a model defined for LS address family in IDR itself. The base BGP model doesn't cover it, and it's not intended to. And as part of doing this work, we're also going to come out with a YANG model for IDR for LS address family as well, because it applies here and we have done the work here, right? So I'm going to talk a little bit more in my presentation, but I thought I'd just let you know the device model is ready.
Okay.
Ketan Talaulikar, Cisco. So I completely agree with Keyur, and at least the configuration model will be different, but the operational model or the view, I think we can share and leverage that for the LS address family in general for BGP-LS.
So that's understandable, but again, from my view, I would say that address family is probably a small fragment in the whole scheme of things. Yes, that is needed, but that's not necessarily, say, the large portion of a problem space.
Okay, Patelarkis, I think you're referring to this system model or a schema, services-based model, which overlays the box-based schema or the device model itself. Is that what you're referring to?
In this case, I don't particularly distinguish the two. The element model and the service model,
Got
this
it.
is what needs to be covered. How do you cover? Well, this is for you to decide. Well, that's basically what I had from my side. Any other comments, any other questions? Not well, thank you.
Yeah, sorry, we have someone working on the mic, so we're going to keep passing this one back and forth. One second.
Testing.
Oh, there it is. It's working. This was off. Yeah, so. All right, sorry about that. Okay, that's all fixed up. So the next item in our agenda is the L3DL update. So Randy was unable to make it, so Rob is hot standby to review this draft with us.
Good morning. You will have noticed that I am not Randy Bush in spite of the fact that I have magenta Comic Sans. So, sorry. Oh. Okay, so remember the basic point of the entire L3DR. I'm probably going to say LSOE half a dozen times because I'm still getting used to the name change. But remember the goal of this is we're trying to discover the topology and liveness. You know, a lot of this is about just detecting when cables are misplugged and the topology isn't what we expected, that kind of thing. And this is for BGP SPF, right? That's the point of all this mechanism. And we're trying to keep it as simple as we possibly can. There's some entertaining discussions within the authors team about how simple that is. Randy and I tend to be, if it's more complicated than a spoon, it's too complicated. Kira likes a little bit more than that, but we're having fun. So again, reminder of how the stack looks. Okay, you've got Ethernet frames, which are the PDUs for this protocol. And we're doing the link checks with the AFIs and SAFIs, and then we're feeding stuff up to BGP SPF. Okay, this isn't a routing protocol. Okay, we're just trying to discover the layer 3 addresses on a point-to-point link. In most cases, these are in fact point-to-point links. Okay, so what's new since the last draft? Sorry, not since the last draft, since the last meeting. What's new in the draft? Okay, so we have this little transport protocol that's built in here. It's very, very small, and it can handle 2 to the 32 octet PDUs. We've tried to make it clear which bit is which. So there's the transport layer, and there's the PDUs layered on top of that. And we try to have a clear delineation between that. The exact number here, 2 to the 24th datagrams, that was last week. I think it's 2 to the 15th datagrams now. We keep fiddling with that, trying to get the numbers right. The problem is you want to have enough to be able to carry the largest PDU that makes sense in this protocol, but you also don't want really ridiculously large numbers of frames flying around with a relatively lightweight transport protocol. So it's a trade-off thing. So the upper frame here is showing you what the transport headers look like. Okay, and it's pretty straightforward. It's just a version number. There's a sequence number so that we can tell whether or not we're doing the same PD we were doing last time or not. That's actually a change. The L bit is still the same. There's the datagram number, the datagram length. There's a checksum because you don't send stuff around raw Ethernet frames without a checksum if you want it to survive. And there's the payload. And that's all there is to it. So you put together a bunch of these datagrams into a PDU. And at that point, you've got a PDU type and a payload length and signature stuff, which we'll talk about in a bit. And you've got some payload. Not much to it. Okay, we're not running TCP. Okay, there's no IP yet when we're doing this, so that's not going to work in any case. We want something lightweight. Randy likes to think of this as TCP-like. I don't think it's that complicated. I used to maintain a TCP implementation. This is orders of magnitude less complicated. This is more like TFTP, but it works. Okay, it's simple. It gets the data through. And we have a little bit of mechanism for being able to deal with retransmissions and out-of-order delivery and that sort of thing, and back off because we're trying to learn from the mistakes of the 1990s and not just flood everything all the time. It's pretty simple. And I think it's stable at this point. We might end up tweaking a little bit more depending on discussions about large numbers of frames flying around and having to retransmit all of them if you lose something. But it's been pretty stable for months now. The stuff above that is a stateful session per peer. Okay, so you've got a relationship between two peers as a session. Pretty straightforward. We do have a way of gracefully restarting now. And this is one of the KR enhancements. It's mostly a good thing. It adds complexity. It's still under discussion, but KR likes to think of this as being very, very much like BGP. I'm an old DNS guy. To me, the mechanism looks a lot like DNS, but it's basically the same kind of mechanism in either case. You've got a serial number, okay? So you send stuff around, and what serial number was that? All right, and then if you have to restart, the open message now has a serial number. What serial number was that I at? And you can have a lot of complicated discussions about exactly how to implement this, but the basic mechanism is trivial. It's just where was I? How do I get to where I need to be? Send me the difference. Okay, we do have mechanisms. We had to add an explicit ACK mechanism because we discovered there were a couple of places where detecting duplicates was a little tricky. So there's actually an explicit ACK mechanism for everything now. And we do retransmit if stuff doesn't. So it's evolving into a small transport protocol, as we said. Hello frames and keep alive frames, PDUs are still different because they have somewhat different requirements. There's some discussion about whether or not we really need the hello and keep alive to be different things. If we were just beaconing the hellos all the time, that would be an indication that the endpoint is still alive, so why do you need keep alive? But the keep alives are intended to be unicast between two peers saying, yes, I'm still here, yes, I'm still here, yes, I'm still here, as opposed to the hello, which is the, hi, I just came up, anybody want to talk to me? In the case of a point-to-point link, which is the usual case, you only need to do the hellos when you're starting up. Once you've got the peer, you know who the address is at the other end. The link layer address is at the other end. You don't really need to keep beaconing the hellos. In a multi-drop thing, we've got multi-access, conventional Ethernet, and it's not just point-to-point. You might need to keep beaconing them so that new people joining get the message. So they're just, these two PDUs, they look a lot alike, but they have somewhat different behavior. So at least for the moment, they're still separate. We'll revisit whether or not they need to be merged at some point. Sorry, I got to this a little early. So yeah, we don't need to repeat the hellos if it's just a point-to-point link, because once you know the other endpoint, you're not learning anything new. Okay, some new stuff. Encapsulation flags we had, but we didn't have, I don't think, the announce withdrawal bit. And I don't think we had the over-under bit either. Care? the over-under bit is new since last. So this is an overlay-underlay thing. If you've got a complex topology and you've got basically a backbone within your rack, and you've got a LAN that you're using just for communication between the Tor and the servers within the rack, but you also want to be able to take things that are inside the rack and have them have public addresses outside the rack. So you've got this overlay-underlay mechanism. The underlay is the conversation within the rack. The overlay is the stuff you're transporting out. So we just have a bit to indicate which kind of address you're talking about for any particular encapsulation, because it makes it easier to sort out which things need to propagate where. We added an explicit ACK and error message. We looked at doing it separately, and the code was 98% the same code, so we just said the hell with it. So an ACK is an error message with an error code of no error. Just that much simpler. Okay, we have this vendor extension mechanism. That was actually in, I think, by the time we were in Prague. It uses enterprise numbers a la MIBs because it was an existing mechanism that's used for extensions and other things. We've actually got a use case for that already with somebody doing something in another working group. It's pretty trivial. Okay, logical link endpoint identifiers. I looked at this and said, what the hell is that, Randy? He says, I just made it up. The problem is that I go back far enough that when I was doing device drivers, Ethernet was called, DICS Ethernet. There wasn't a lot to it. These days, layer 2 is a complicated ecosystem with multiple layers of stuff. And sometimes your MAC address isn't really your MAC address, or your MAC address isn't really an endpoint identifier, or there's a bunch of bonding stuff going on, or God only knows what. So in a simple DICS Ethernet world, your endpoint identifier would just be your MAC address, but sometimes the topology is more complicated than that at layer 2, and you need something that's your system identifier. So it's a something, abstract concept system identifier, and which interface did you receive this on? That's generally the endpoint identifier in terms of what you're writing in your code. Okay, and there's a question, do we need a mandatory to implement link layer endpoint identifier? That's still under discussion. We don't know yet. Okay, so we have 2 implementations. There's my somewhat older one in Python 3, which hasn't been updated since we changed the name from LSOE, so it's still called LSOE. There's a new one from one of our coworkers in Golang. We're planning on putting this stuff into our operating system, and we're hoping maybe we'll be able to do some kind of an interrupt thing in Singapore and send this stuff to last call. Still up in the air, but that's the hope. And as I mentioned, we've already got somebody using the extension mechanism. So Neeraj has this thing over in BEST, the EVPN mechanism. Okay, we really want people to review the draft. Randy says this every time. It's still true. Please review the draft. It would be nice if we could get review before having to send it to working group last call just to wake people up. I want to specifically acknowledge Paul Cont'd. Thank you for having repeatedly reviewed the thing for us. Very much appreciated. But it would be nice to have other people too, please. Okay, and that's it for the main protocol. The other one is, this is like 60 seconds, okay? So we added another PDU type for transporting around sort of the minimal upper layer protocol configuration information. That's really it right there, this one slide, okay? We're really hoping to keep that to the minimum amount of necessary configuration stuff. We don't want to turn this into all of BGP again, just what's the minimum you need. KR can speak more to what actually needs to go in here than I can, but that's pretty much it for the other one. We don't want to be replacing BGP. We don't want to be conflicting with BGP. That's part of the reason for keeping it minimal. The less you say, the less likely it is you're contradicting something. Yes, KR.
KR Patel Arcus. This is the minimum requirement needed to exchange BGP data so that you can establish automatic peering between 2 nodes.
Okay.
Kind of like BGP discovery, if you will.
Yeah, pretty much. Okay. Okay, so here's the explanation of what we have currently spec to go in for BGP. Okay, so you've got your ASN, your V4 peering address, prefix length, BGP authentication data. Okay, that's it for the main preso. I did not do any slides for the signing mechanism we've been working on because actually the draft isn't published yet, so there's no point asking you to read the draft. But we've managed to keep it very, very simple so far. I'm just going to talk about it for 1 minute. It's basically just signatures. Okay, and there are 3 levels you can do with this. You can have screw it, I don't care about signatures at all, in which case you leave the signature field empty. You can have what in the security world is called tofu, trust on first use, where it's like, I send you a key and you say, okay, I've never seen you before, but fine, whatever. The rest of this session will be signed with this key. Okay, fine, whatever. So all that proves to you is that somebody hasn't jumped in and hijacked the session. Sometimes that's all you need. Depends on your operation model. The 3rd level is very, very lightweight PKI. Yes, the word PKI is scary, but we had help from a friend who said, no, you do not damn well need X509 here. So the PKI is basically just a signature. The certificate literally consists of a signature by a certification authority. That's it. All it's telling you is this L3DL speaker is an authorized member of the group, as opposed to, say, the janitor's laptop. That's all it's telling you. If you care about that level of assurance, the mechanism is there. If you don't care about it, you don't have to use it. We've got the draft mostly written. It should be ready within a month or so at the most, and certainly ready for people to review by the next meeting. That's it. Questions?
On that authentication, Paul Congdon, sorry.
Yeah.
On that authentication, how big is that signature at currently? Do you know?
It depends on the algorithm, but it's not huge. We're using the 3 algorithms we're talking about are all elliptic curve algorithms, so that this is not. Okay. Russ, how big is DSA? I'm forgetting. ECDSA. Sorry. 32. So 32 bits, and the other.
Okay.
Bytes, yeah. So, it's noticeable, but it's not huge.
Yeah, it's not going to.
Right. And the other ones we're looking at are on that same order of magnitude.
Yeah, okay. I had a great update on this draft. There was a lot of changes and clarifications. But then the additions of the overlay, underlay thing brought a lot of questions up for me anyway. So that's primarily for the, I would say, the Genie VXLAN style overlay underlay. You don't consider a VLAN layer 2 as an overlay underlay, right? I think the VLANs are actually why you also modified the LLEI, or created the need for an LLEI, because over a single Ethernet wire you may have multiple VLANs, which results in multiple interfaces, and that I think is that accurate?
I'm going to invite Kier to respond to that.
Yeah, that's correct, Paul. Kier Patel-Arcus. And this is also assuming, say, for example, a server has an overlay addresses in a manner that can be made accessible at the layer where L3DL can announce it out. If that happens, we need just a bit here that can differentiate, saying this is an overlay versus an underlay address. Yeah.
So effectively that allows you to sort of aggregate, rather than having to run instances of stuff at that layer. I'm wondering if you can do a similar thing at the VLAN layer, because what I'm seeing, right now, I think you're running an instance of L3DL per VLAN, and the hellos and potential keep alives might generate a lot of chatter. I'm wondering if there's a way to do a similar approach of that as well. Anyway, it's a thought that fundamentally, when I talk about LLDP, that's kind of one of the benefits of LLDP. Kind of runs below the VLAN layer, so to speak, and so you have the ability to aggregate that stuff. So, but anyway, I think so. That was my other question. Just to be clear, the LLEI, if I was running multiple VLANs on a wire, I would be using the LLEI to identify which instance of VLAN effectively that's running on. And a system identifier could be like MAC identifier plus a VLAN ID or something like that, maybe, right?
Yeah. Kier Patel-Arcus. Paul, it would be great if you can send that out on a mailing list. Sure. I think that's a great topic, because most probably I'll forget, but I'll pick it up on the mailing list or an email. Okay. That would be fantastic. Thank you.
Okay. Thank you, Paul. Anybody else? Okay, thanks.
Thank you, Rob. All right, so the next slide will be an update. I think, Paul, you're doing the update for LLDP v2. I'm going to come wander back there. Are the blue sheets back there? Has everyone had a chance to sign the blue sheets? Okay, I'll come walking around. Go ahead.
Okay, thanks. Okay, I'm Paul Congdon, and I'm also acknowledging Paul Bottroff. He's not here, but he is working on with me on the IEEE to kind of help do this definition. So we have a project, 802.1 ABDH. I can give you the whole IEEE decoder ring for all the letters if you're interested, but fundamentally this is what we call LLDP version 2. So first major disclaimer, I'm an individual here. I'm not speaking on behalf of IEEE, so I'm just telling you my perspective of what we're doing here. So just as background, you can look at these at your leisure. We originally proposed a update to LLDP back in January, and then we did sort of an initial first cut of evaluation against the LSVR requirements, because the objective was, could we try to support what LSVR needs by making modifications to LLDP. There's been some liaison exchanges back and forth between the IEEE and IETF on the topic, we now have a project approved. There's some final logistics within the IEEE to actually get it, fully staffed, but we're at a point where we can kind of move forward. So what was kind of driving all this? From our perspective, it's kind of like discovery protocols going wild everywhere. There was the work in LSVR, as you guys all know about. There's also been some other discovery in the IETF, such as the IDR, neighbor auto discovery. We even worked with the IETF on the virtual station interface discovery protocol for NV03. And that takes advantage of LLDP, but sometimes the amount of information that needs to be exchanged there is large, so LLDP doesn't always fit perfectly. There's also another project in the IEEE called Auto Attach, which does assignment of VIDs and ISIDs, if you're familiar with provider backbone bridging. That also runs into size limitations with LLDP, but it's effectively an application running on top of LLDP. So there's a lot of use, a lot of need, and we were really stretching the needs for LLDP. So it was clearly time to do something and revise that protocol. As we all know, it's pretty widely deployed. People have, kind of quote used it in many different ways, many different environments, not, data centers to wireless networks to, campus LANs. There's a facility to define your own information, either as a standards organization or as an individual vendor. And people have come up with all kinds of use cases. So the amount of data that people are wanting to send just keeps growing. So we needed to start this project. And so the fundamental thing was to scale it to allow what we're calling this informally LLDP applications, or people that use LLDP data. We want to be able to scale the amount of data that they can share. And clearly LSVR requirements were one of those things. We also had requirements we're doing time sensitive networking, DetNet style stuff in the IEEE as well. And there was a need to actually go the opposite direction and shrink LLDP PDUs so that you can schedule them and mix them in with other traffic. So that's a facility that we're also doing. So this project is an amendment to the current standard, and it's going to allow what we call TLV databases to consist of multiple frames. So think of what you have as a database. It's just a bunch of TLVs. So in LSVR, you have the IP address encapsulation list of various things that node has. That's part of an overall database that it wants to share with its peer. So just think of it as, a generic database. And now that database needs to be bigger than what can fit in a single layer 2 frame. So anyway, let's see what else. One of the key advantages too was to allow this new version of LLDP nodes to still talk to the old version as though they were an old version. So if you have LLDP running all around anywhere else in your new updated version, you can still exchange that first frame's worth of data and everything is fine. It's just you can't do more than one frame to an old version. That guy has to get upgraded. So anyway, we think just the facility and the way in which we're doing the extension should satisfy a lot of discovery needs for many of these new use cases that are out there. So what were some of these objectives? First one is to be completely transparent to the users of LLDP. So again, like an application that's expecting data, we don't want that application to have to change at all. It's just now allowed to send and receive more data than it used to. So from the user level, it should look the same. And so we want to support, more than one frame worth of data. I think initially LSVR requirements were around 64K. They may be bigger now, it looked like, or at least you have the facility to send lots of data. And then of course, we want to, as I mentioned, for time-sensitive networking, we also want to shrink things if possible, or have the ability to configure it in a way to shrink the data so that you can schedule it. Again, communicate with version 1s. It should work over shared media, although we're going to really more or less optimize it for point-to-point. So that'll be the better use case. And one of the key things is we want to make sure we're ensuring that the integrity of that data, so we know that we've received everything that peer is trying to advertise, if you will. And that would be a useful feature even in version 1 implementations. Some people have implemented their own way of doing that. Another key thing about this new proposal, so changes in the most recent proposal, is that we support what we're calling pacing of frames at the receiver. So in other words, instead of just blasting out a ton of frames to a node that only has one buffer, for example, we're going to allow that receiver to consume the data at whatever rate it needs to. So if it's a rich implementation with a lot of memory, it may request a whole batch of frames, but if it's a very lightweight IoT type implementation, it may just get that data one frame at a time. So it's receiver paced. And that was a key change in the latest proposal. And again, we don't want to really try to increase network traffic. We're going to send more frames. As you know, LLDP is a periodic protocol. Every so often it just sends out the one frame. So the version 2 will look exactly like that. There'll still just be one frame that gets sent out. However, if you need the extension data, a receiver will ask for it and then you'll transmit it. So we won't just be multicasting stuff all over the place. And then since we have the book open, if you will, and the pin to modify it, let's look at maybe some other things that might be of interest. So maybe supporting a larger TLV itself. Today, the size is restricted by the format. We could consider larger formats for extensions. And I know the authentication idea is a high want here. You guys have a draft in play for that. So that could be an example of something as well to consider. Okay, so just as a quick reminder, this is how the current operation works. Very simple protocol, widely deployed. Think of these as, again, we think of them as databases. That's just, you have as a local agent, I have my local information I want to tell people about. So just periodically I send it out. And the receiver gets that and he compares with what he got last time. If it's different, he signals the application that something's changed and he updates everything. So the entire database got updated. And then if you change something locally, that'll trigger the transmission quicker. So it's very simple, protocol, not too complicated. So the proposal for the new thing is to define, use the current frame format for the level 1, but define a new PDU or a new TLV in that PDU. So again, we still have the same version 1 frame. And an LLDP1 implementation would be able to receive it. But we'll define a new LLDP extension PDU, so a new frame. And what we'll do is we're going to describe those new frames in a manifest. So the first frame that we send that looks like LLDP v1, it'll have an additional TLV that has effectively a manifest defining all the other TLVs that are out there. So then when you receive that, you'll be able to know if you have all the extension data or not. And if you don't, then you request it, frame at a time or batch at a time, whatever you want. So that's the high level, that's kind of how it works. So yeah, the manifest defines a way to identify each of the extension frames. And again, the transmission of those extension frames is going to be controlled by the receiver. He's going to pace it at what rate he wants. I think that's pretty clear, and I'll go into the details. And another important attribute is we want a version 1 implementation that receives an extension PDU to basically ignore it. Because if you recall, a version 1 implementation, when it receives an LLDP frame, it throws away everything it knew before and replaces it with this one frame, new frames worth of data. So we have all these extra frames that are extension frames. We don't want an LLDP version 1 to even see them. So we have to think about how we do that. And there's various ways, including, getting a new ether type. But I think the current proposal, we're going to try to do it without getting a new ether type. And so these new PDUs that have all the extra data, they'll have a new format. They'll still have the chassis ID, port ID, so you know who came from, the peer. And then they'll have some way that identifies them, like I'm frame number 5 of 10, and that'll be a new part. And then the rest of it will just be TLVs. They could be new formatted TLVs, or they could just be the existing ones. We'll have to decide. And then there's this new, again, request for extension message. So this is, again, how the receiver says, okay, I'm missing frame 5, please give me frame 5. Or I'm missing frames 1 through 7, give me 1 through 7. And then once the receiver has everything, he knows by the manifest that he's up to date, and he can signal the application that the data is available. So this will support, again, shared media as well, multiple peers on shared media. It won't be as optimized for shared media, but it'll work there. Again, we talk about receiver pacing, and you will only ask for things that are out of date. And then there's no change to the periodic transmissions. You'll still periodically transmit the first frame with the manifest. And the TTL would rely on that. So in this situation, same agents, remember, they just have more data. They have this manifest that's required in the base TLV. So when something changes locally, you'll send out that first frame. And the receiver will get that, and he'll look at that manifest and compare and say, I'm missing some frames. So he'll send a request for extension, and that'll be a unicast packet. It won't be multicast. It'll be unicast back to the sender, and then he'll send those extension PDUs as he needs. And once the receiver has collected all of that data, it'll signal the application that something's changed. We've got a new database. And so again, from the application's perspective, everything looks the same. And then after everything settles and nothing's changing, it just looks like regular LLDP. You're sending out your periodic frame with the manifest. And if somebody new joins, they on a shared media, they would see that and pick up from there. Okay, so as I mentioned, we had done an evaluation sort of what LSVR requirements were. And if I were to just say at 50,000 foot, that your LSVR is doing a couple things. Like I said, it's exchanging a database of information, encapsulation types and things, but it's also doing this layer 2 liveness, and it may have an authentication scheme and some vendor extensions and things like that. So if I look at with our new proposal, can we support these things? These is sort of the guesstimate. Yes, I think obviously the LLEI is just a chunk of data, relatively small. Attribute list is the same. We would just define a TLV. The authentication data we need to see. That's why I was asking the question about the size, because would it fit in a current TLV, or do we need to grow the size of a TLV? I think the encapsulation and addresses are fine. One thing to keep in mind, and this came up in a hall conversation, there's multiple types of TLVs in LLDP. Usually you just receive one of them, but it's possible to receive multiple of the same TLV type. So in other words, if I have, let's say, a layer 3 encapsulation TLV that I define for LSVR, and I need to send more encapsulations than will fit in one TLV. Well, I just send multiple of those TLVs. That works. You don't have to, you only have one TLV of one type, so you can replicate stuff. So keep alives the way they're defined in L3DL right now, every 1 second. That's a little bit too fast for LLDP. It's not really designed to scale that way. So we would be looking for alternative ways to try to address the layer 2 liveness requirement. The ACKs are sort of an implicit part here with the manifest and knowing that you've got things. And then we do have vendor extensions that's already exists today, and it's been widely used. So I think in general for the information exchange that we need, I think we should be able to do it. So if we wanted to try to say, hey, when we were going to use LLDP for LSVR requirements, what would really need to be done? Well, I think the first thing would be we need a draft to write to describe these new TLVs that are specific to the IETF. So we would create an internet draft that described the format of those TLVs. We already have pretty much that format defined in L3DL. Maybe that format works as is. Maybe it needs a slight modification, but we would just use LLDP as a transport rather than L3DL or in addition to L3DL. So we would need a draft for that. We would say consider some alternatives for liveness. There's a standard we have, connectivity fault management. It's pretty widely deployed as well. Check your local Broadcom chip. It's probably already in there. So that already does layer 2, liveness requires some configuration, but that's there. And then of course, make sure as we progress this LLDP v2 standard that, it's staying within, it's meeting the needs of LSVR. So providing technical input review, I'm sure we could set up some liaison style way of sharing documents that's open and everybody can play. So that would be another suggestion. So anyway, that's it. There's so the next steps for the project itself is we're in the technical contribution phase right now. Love to see open source implementation, taking the LLDPD and forking it and adding these things to prove it out. We're going to go through an evaluation of what actual text changes need to happen to insert this into the Dune document. And then at some point in the near future, we'll create a draft by an individual contributor. And then at some point, an editor would be assigned. We're still waiting for the final formal approval from the highest levels of IEEE, but that's expected in September 27th. So that's kind of where we are. I have a whole bunch of frame formats and stuff in the backup if you want to take a look at that, but I don't think we need to cover that. Is there any questions?
Hi, John Scudder. So this was a sort of compelling ad, good elevator pitch, and I was glad to see your bullet that you just spoke to on the last or second last slide. You don't have to go back where you said we can come up with a way to provide the spec so that people can read it, because that was like by the time you had gotten through your first few slides, I'm sitting in the back thinking, okay, where can I go grab the spec and read it? Because it's great to see slides, but until you get to read the spec, So I would look forward to getting some info about where to grab that spec.
Sure.
As pretty much the next step.
Yeah. So that when we do draft developments of the specs, it is a working group only document, so they're password protected. It's kind of a widely known password, but I didn't say that. But also we have means for, formal liaison between standards organizations to make those drafts available. So, Janos, task group chair.
Janos Farkas, yes, there is that password, but anybody can be a working group participant. It's really easy. Just the official way is just contact the working group chair. You get the information. So we have a lot of contributors. It's an open organization.
Right. It's not difficult to join and become a working group member. I'd also like to add that during what we call the task group ballot phase, which is, the early phases of the first draft, we pretty much will accept comments from anybody. There is a process, but we typically are going to take input from anybody. So, you don't have to be voting membership and all that kind of stuff to make a comment on the draft.
Exactly. Any phase actually, comments are accepted from anyone and treated equally. You don't have to be a voting member. You just contribute, comment. Even in the very last stage where there is the
sponsor ballot.
Even in sponsor ballot, there is IEEE has an official way to accept comments from anyone.
Yeah. Yeah, So there were, at the early slides, there's some pointers to our public web docs where you can see the current state of things to
If
that
you have questions,
presentations.
contact us. Like,
Yeah, of course.
We're happy to help on how to get access. We don't have draft yet, so as Paul keeps saying, contribution driven. I think it's contribution driven as well. So we need to. We cannot give you a draft yet. We need to have contributions first.
Correct. Okay. Any other questions? All right.
Okay, thank you, Paul.
Thanks.
All right. Might need to be closer. All right, so our next presenter will be Kier. Did I surprise you? No? All right, for the BGP SPF draft update.
Did it work? Does it work?
Yes, it works.
Morning, folks. I'm going to give a quick update on LSVR, BGP SPF. From a status standpoint, the draft was updated on Sunday by AC. It's in a fairly stable state. We have an implementation now on it. Full implementation is now done on the spec. There is another implementation that is also on the way, probably from an open source community. And at least 3 operators have signed up to test and evaluate the protocol itself to see how it operates. From a class standpoint, it's fairly stable. As part of implementing the draft, the Yang model is already in place. Like I had mentioned earlier, the formats of SPF reuses LS SAFI of BGP itself. So when we designed the model, we naturally designed the model for LS SAFI also, and we will come up with a draft for Singapore IETF. Again, the model itself is fairly straightforward. We do want to start working on, while we work on the models draft, we do want to start working on protocol implementation draft and probably an experience draft if possible. People keep on telling me that this is a new protocol, while I tend to think of this as just a BGP SAFI extension, but if it's a new protocol, we probably should have an implementation and experience draft. From an implementation perspective, all sections of draft have been implemented, pretty much all of them. There was challenge in generating, in some cases, what the remote router ID can be when the servers don't run BGP SPF, or when you start to have a peering model that is reflection based, which is not an in-band peering model. We basically gathered this information either from LLDP or L3DL, the protocol of choice. We figure out who's the remote endpoint on the link, use that information to source and compute SPF as we need. Then again, BFD is always used to leverage for a bidirectional link verification. So we do that using BFD. We make sure BFD is turned on, and as long as the link is up, the neighborship is up. Finally, from interop also standpoint, we ran this against different IGP protocols. As draft has mentioned, it does give higher preference to LSVR. And from that perspective, when you start to do tie breaking, it's pretty straightforward, where you take LSVR routes as a preference, give them a higher preference, and install them in FIB forwarding. So from an implementation standpoint, it's fairly simple and straightforward. As soon as we get second implementation from the open source, we like to start doing interop. The draft, that's all I have. The drafts, like I said, again, in fairly stable state. We would really welcome reviews at this time. Any feedback, comments would be appreciated. Because the implementations are underway, we can change it if needed, or else consider pushing it towards a last call. Probably seen at Singapore IETF and maybe later.
Yeah, I was going to address reviews, whatnot, at the end as part of the closing, but generally agreed that we'll need to get reviews going. But we'll let Q&A first. Any questions?
They always told me Replacing distance vector in BGP is nearly impossible. Ha! It's done now.
Okay, I guess that's it. Thank you, sir.
Thank you.
So that's the end of the draft reviews for this agenda. We did want to cover a couple of closing comments and the next steps at this point. So we just spoke of it now, and there's a number of drafts that we have that have matured over the last while. And we do need to get some kind of re-identify reviewers, and why we want to get those reviews done for two basic purposes. We have drafts we think are mature, but it's really important to get a bit of a better cross-section review so we can actually validate that, make sure that we have something we can actually take to working group last call. What I'd like to do is identify those on the mailing list, and we're going to look for volunteers. Now, just as a show of hands, I want to figure out what I'm going to face on the mailing list here. Who would be willing to do reviews for some of these documents that we really require reviews for? I'm not suggesting you're committing right now for the review, but I need to try to get an assessment, or we're trying to get an assessment of whom will actually be able to dig into these documents and help us make sure we flush out some of the data there. So just trying to take a test here. Show of hands if you would be willing to do a review. No, I'm just in general, like there's some document that we've reviewed that you would be willing to review. So I have a few hands. Okay, so Rob's kind of interested. Yeah, you shouldn't review your own document. Even if you do a good job, checks and balances. Okay, so we have a few. We're going to probably then solicit a little bit more. Looks like I had about 7 hands, maybe 8 there. We still want a bit of a wider selection of reviewers, so we're going to have to figure out how we're going to drag a few folks in to help us there. I'm not sure how we're going to bait everyone. But that's going to be our big bar at this point. We do know we have the LSVR, sorry, you put notes up there, great. We do have the Yang work to kind of work through. So Agnes, thank you for bringing it up to us. We'll make sure that we kind of get that going. I think we're a little maybe behind there. I'm not exactly sure. We're going to try to catch up because that was one of our key deliverables that, it's important to operationalize this. So expect over the next week or so, I'm going to have to work with Gunter to figure out how we're going to drag people in to get these reviews done. To me, that's the biggest bar we have at this point, to make sure that we're ready for actual work group last calls. So I really don't want to go up the chain with documents that then receive review post us, sending them up. Is there any other comments you have at this point? Okay. So I do appreciate everyone coming out. We did have a bit of a short agenda, but that's okay. We had lots of room for any Q&A. Now, before we break, is any last comments? Anyone want to say anything to the mic? Okay, blue sheets. Who has the blue sheets? There's one up here, one back there. I'll come. So thank you very much. That concludes the working group.
Someone translated in Chinese. You made it? I have a problem. I was making a note of my data package. Not like online, but like everywhere. I was typing the guy doesn't know that it's well, have you seen what's his name? Adam. Yesterday.
Yeah, not today.
I don't think I will be doing very much today.
Yeah, I wanted to stay in my room, but then the cleaning lady came in, and in fact, she was. No, but I don't have much this morning. But in fact, whenever I'm in my room, I have problems with the network.